dia tu? Ada dah. Kita tengok dekat YouTube. Live. Okay, live. Okay, stiffness method beam. Okay, as usual, we have to define the degree of freedom according to unconstrained and constrained, right? Because from that we can identify the zero displacement or zero degree of freedom. Zero displacement ni sometimes is also called as zero ni zero displacement kan? This means zero displacement. Sometimes it is also called as zero degree of freedom. So if this occur in constraint system, in unconstrained system, nama dia non-zero degree of freedom or non-zero displacement kan? Displacement. Okay, so we have just now label the degree of freedom. 1 and 2 is located in unconstrained system because in this beam, if we draw the deflection, right? If we draw the deflection, deflect like this, deflect like this, deflect like this kan? Deflection, right? So we can see clearly that there are rotation at B and C, theta B and theta C. Okay, so this is for nodal forces and nodal displacement. Nodal means node. So kalau nodal forces means force that is directly subjected at nodes. Okay, Q1 means moment. Look at the diagram, there is no moment. Okay, so the value is 0. Q2 means moment at C, and again there is no moment at C, so the value is 0. Q3 until Q8 is reaction at the support because it is occur in constraint system. Okay, for nodal displacement, label number 1, label number 2 for displacement is representing rotation at B, rotation at C. Okay, and there is no deflection at support. So from label 3 sampai label 8, the value is 0. Right. Share. Okay. Okay, beside this, we have to define also Q0. Problem kat Q0 Okay, it is Q minus Q0 is equal to KD, or Q samalah, right? KD plus Q0. Okay, so let's say we want to determine Q0. So whenever we want to determine D1 and D2, we need to consider the equivalent nodal forces occur at element 2. Here is element 2, right? Element 2. Okay, so for element number 2, okay, we want to analyze equivalent nodal force Q naught. Okay, and Q naught is equal to Q, how many element? 3, right? 3 elements. So 1 naught, 2 naught, 3 naught. And for element number 1, there is no applied load along the member at any point on the member. Okay, same as element number 3, right? So Q1 naught is okay. It has 4 degree of freedom because 2 at each node, right? So it is 0, 0, 0, 0, Okay, near is 3 4, far is 5 1. From left to right as usual. 3 4 5 1. This is the same with scale. 3 4 5 1. And for Q3 naught, Q3 naught 0 0 0 0 0 0. And the label is what is the label? 6 2 6 7 8. Okay, we always say the Y first followed by Z. 6 2 7 8, right? 6 2 7 8. But we need to calculate the Q2 naught because of the UDL, right? So for element number 2, okay, what we need to do is I want to extract that particular element. This is element 2. At element 2, node is B and C, right? B and C. So this is B, this is C. B and C. Then the label is 5162. 5162. It is 5162. Okay, 5162. For B, the arrow is always to the right side, so we don't have to put. Okay, so to determine this value, the Q naught value, Q2 naught value, so since it is subjected with UDL, so we refer to appendix page 3. Appendix page 3 for fixed ended beam. UDL like this. Okay, let's say the value is 20 kilonewton per meter, the W. The W is 20, the L is 5. Okay, so this is 20 kilonewton per meter. This is 5 meter. Remember that fixed end moment is behavior. So to maintain equilibrium. Okay, this is the reaction at the support, the vertical reaction, and the fixed end moment. Due to the load shown, this is the behavior. So for the vertical force, it is 20 times 5 divided by 2, right? 100 divided by 2 is 50. This is 50. Okay, and for the moment, it is W L squared over 12. Please calculate W. W 20 W L squared, L squared 5 squared divided by 12.
20 times 25
Okay,
41.67.
41.67 both. Like this. So now we want to establish Q2 naught, right? This is for element 2. Element 2, remember the degree of freedom is for this is 5 1 YZ 5 1 6 2 5 1 6 2. Okay, find the value of 5 from the second diagram. 5 is 50. So 5 is 50. Okay, 1 is 41.67. Okay, 6 is 50. And 2 is negative 41.67. So for Q naught is Q1 naught plus Q2 naught plus Q3 naught, right?
Yes.
Okay, so it is matrix
0.
Okay, 1 is wait. What happened? Okay. Okay, one is 41.67. It is 41.67. 2 is negative 41.67. Negative 41.67. 3 4 0 0 0 0. 4 3 4 0 0. 5 is 50. 5, right? Ni 5 is 50. 6 is also 50. 6 is also 50. 7 8 is 0 0. So we put into the equation, consider unconstrained system, because D is 0, right, in constrained system. So it is equal to Q is equal to Q is minus Q naught is equal to KD, right? So Q just now 0 0, right? Since there is no moment at B and C, so minus Q naught means minus 41.67 and negative 41.67. 41.67 negative 41.67. Okay, this is equal to K as usual lah, K, right? K times D. D1 D2. And then solve this, we get the D1 and D2 lah. Okay.
Kalau so okay, we can determine daripada sini kan, local kan medium kan?
Local and global has the same. So for example kan, K1 it is 4 by 4. It is 3451. 3451. 3451. 3451. Okay, so use the formula. Length for element 1, length is 5, right? Length is 5. EI is constant first. EI is constant. EI like this. So it is 12 divided by L cube. Okay, try
12 divided by
L cube.
.0.096.
This is 0.096. Okay, second value 6 divided by L square.
0.24.
0.24. Okay, 24. This one again the same, right? Negative. It is negative. Negative 0.096.
0.24.
0.24.
0.24.
Okay, this next value 4 divided by 5. 0.8. 0.8. Okay, next 6 divided by L cube. 0.24. Negative. Negative 0.24. Okay, 2 divided by L. 0.4. 0.4. Okay, next 12 divided by L cube. 0.096. 0.096. 0.24 negative. And last one 4 divided by L. 0.8. 0.8. Okay, actually the stiffness matrix for the element, right? Since L is same, so we get all same for K2 and K3, isn't it? And K2 label for K2 is K2 5162, right? 5162, right? This is 5162, 5162, and K3. 6278. 6278. Is the inside value is equal. Right?
Because the distance is same, right?
Yes, because the distance is same. So, okay, now (0.096), 0.24, negative 0.096, 0.24, 0.8, negative 0.24, 0.4, 0.096, negative 0.24, and 0.8. So equal lah. So 0.096, 0.24, negative 0.096, 0.24, 0.8, negative 0.24, 0.4, 0.096, negative 0.24, 0.8. And since we know that to determine D1 and D2, we need only to consider the unconstrained system. So we want to fill in with value, right? Okay, so
K2.
1 1. So it is 2 by 2 matrix, right? This is EI, right? And times with D1, D2 equal to this 0 minus the negative 41.67, right? And here is positive. Ni positive, right? Positive 41.67. 41.67. Like this. So this is 1 and 2, right? So 1 1. Please find the value for 1 1. 0.8 plus 0.8, 1.6. This is 1.6. Okay, 1 2, 1 2. Where is 1 2? 1 2, 1 2. This is 1 2.
0.4.
0.4. This is 0.4. 0.4. Okay, 2 2. So 2 2, 2 2 2, 0.8, 2 2, 0.8,
1.6.
1.6.
Lepas tu two unknown.
To unknown.
A dia is 1.6.
1.6. We get the answer.
B1 dia
B1 0.4,
negative
41.67. 0.4, 1.6, 41.67.
So negative 34.
Okay, so D1, D2 in terms of EI, because we don't put the EI value, right? Okay, so means the answer must be divided by EI. So 1 over EI. Negative 34.725 and samalah 34 positive 725. So if EI is given, then we can get the EI lah. We can get the displacement in unit radian. Okay, so this is the answer for the rotation lah. So in unit radian, because 1 and 2 represent rotation.
Alright.
Okay. For the Q, as usual lah, Q. Let's say we want to calculate Q, right? Let's say we want to calculate Q3. Now we want to calculate Q3. Q3 means we have to consider line number 3. If we want to calculate Q4, we need to consider line number 4. So line number 3 tu, we need to consider the value of 3.1 and 3.2, because 3.1 we want to times with D1, right? And 3.2 we want to times with D2. Can you imagine? The matrix tu, the overall matrix. If we want to calculate, let's say if we want to calculate Q5, so we need the value of 5.1 and 5.2, because 5.1 time with D1. 5-2 we time with D2. 5-3 we time with 0 because D3 is 0. So we need only 1 and 2. 1 and 2. Since the value that we need is only 3-1, 3-2, 4-1, 4-2, 5-1, 5-2, 6-1, 6-2 until 8-1, 8-2. So let's say we want to calculate Q3.
So
Q3. So we need 3-1 and 3-2. So find 3-1 from the matrix. 3-1. Okay, where is 3-1? 3-1, different color. 3-1. Okay. 3-1. This is 3-1. 0.24. Only that one, right? Okay, 3-1 is 0.24. Okay, this is 0. EI 0.24. 3-2. Where is 3-2? No 3-2, no 3-2, no 3-2. So 3-2 is 0. 0. So this we times back with displacement. Displacement is 1 over EI times with negative 34.725 and 34.725. Okay, plus back with Q3. Q3 is 0. Can we go back to the equation, right? Equation is Q minus Q naught is equal to KD. Whenever we want to calculate Q, so we have to use this formula. Q is equal to KD plus Q naught. So now we calculate Q3. Q3 is Q kan? So we consider this. So this must be plus with 0 lah. 0 because at position 3, Q, where is the Q? Oh ni position 3 kan? 1, 2, 3 kan? 4, 5, 6, 7, 8. If you want to calculate Q5, for example, Q5. This is Q3 kan? Okay, Q5. Let's say Q5. For Q5, okay, EI. So this is the example without EI value, right? Okay, Q5, we need 5-1, 5-2. So find the 5-1 and 5-2 in K1, K2, K3. Okay, 5-1. 5-1 in this 5-1. 5 negative 0.24. Negative 0.24 and 0.24. So it is 0. It is 0. So 0. This is 5-2. 5-1, 5-2. 5-2. 5-2 is 5-2. 0.24. 5-2. Any more? No. So it is only 0, 6, 2, 7, 8. No. This is 5-2, right? 5-2. 0.24. So only 0.24. So this is 0.24. What is this? This is 5-1, right? 5-2, right? Okay. Times with displacement. Negative
34.725 positive.
Okay, this one we must plus with
0.
no. At position 5.
50.
At position 5 it is 50. So we need to plus 50. Okay, so value dia to please check 0.24. We want to check the value. 0.24 times with 34.725 plus 50. So what's the answer? 58. So it is 58 kilonewton or kilonewton meter. Check. Position 5 represent what? Position 5. Position 5, this is position 5. So kilonewton. Kilonewton. As simple as this.
Dia yang 50 tambah 50 ni madam, dia asalnya daripada Q note kita
Yes.
tadi kita
Yes,
tu kan.
yes,
Alright.
yes. Yes, this is Q note. Okay.
Okay.
So simple.
So simple.
Kan? Except this example is very straightforward because all leg is equal kan. And there is only one UDL kan. Element 1 and element 3 don't have any external load kan. So step is macam ni lah, like this. So means that the important is K for element, K1, K2, K3. That is very important.
Sebab bila ada external load K, dia akan dia punya tu lain
No.
Dia akan berubah
The important is the important step that we need to we cannot neglect is K1, K2, K3 tu, the element stiffness matrices. The structure stiffness matrix do not need to determine in the question. Only if the question ask to do. Just do like this lah, like what I have shown to you just now kan. So the most important thing for K, if we know that the degree of freedom is 8 by 8, so we can imagine K tu is where is the position of 5-1, where is for the position of 6-2. We can imagine that. And then we want to solve for unknown displacement like this. If EI is given, we can consider EI. But to solve for the answer for displacement, we don't need EI actually. Okay, if we have EI, we can also determine like this, and final answer, then we divide by the EI value, then we get the rotation in unit radian. And then if you want to calculate Q also, we don't need EI value because EI here and EI here can be cancelled off kan, cancel right. So we get like this. So even though we don't determine the K in full, if you want to calculate Q5 like just now, Q5, so we know that it is 5-1 and 5-2 contributed. 5-3 until 5-8 because the times with displacement 0. So that is why we don't consider that, right? Except when there is the effect of settlement then we need to consider. So the most important thing is the K, the mathematical concept lah. Okay. And for the equivalent nodal forces tu, I advise you to do like this, these two comparison. More clearer lah than you other method kan. So do two diagram like this. Okay, one is for the DOF and another one is come from the formula itself kan. Formula itself, find the value. Okay, find the value like this. Find the value and just compare. Then we get this. Straightforward. Okay. So term kena you must understand the right term. For example, if the question asks you to calculate the non-zero degree of freedom, what does it mean? Non-zero degree of freedom to represent deflection. Inilah non-zero degree of freedom, because the degree of freedom itself is displacement component. So when we divide into these two systems, unconstrained and constrained, we can see clearly lah which is zero, which is non-zero. Kan, where is the unknown displacement occur, where is the unknown displacement occur. So we can see clearly. So that's what I said. Stiffness method ni is the compared to these three topics kan, this is the easiest one. Okay, ni dah boleh score lah actually.
Flexibility method test also.
I don't want lah between three type of structure. Okay, thank you. That's all for today. Assalamualaikum.